Dystopian future world of the Hunger Games, the nefarious capital provides rations of food to the various districts that surround it. Now, the farther a district is from the capital, the less and less rations of food it gets, and the more poverty there is in that district. Let's say for simplicity right now, there's only 3 districts, District 1, District 2, and District 3, which are at a distance of 10 miles, 20 miles, and 30 miles respectively from the capital. Now let's say as researchers, we're trying to figure out what is the relationship between your age and how many rations of food you get per month as a person living in this Hunger Games universe. So we want to figure out, is there some relationship, is there some function that can tell us between how many rations of food you get every single month, and is that a function of your age? So, trying to figure this out, we go to all 3 of these districts and we survey a bunch of people. We say, hey, what's your age and how many rations of food are you getting per month? Now let's say we want to try and model this by a linear relationship, just to keep things simple. So we say that we think that the number of rations of food you get per month is modeled by some beta naught intercept plus some beta 1 coefficient here, the slope, times your age. Now this is all well and good, and let's look at what our data looks like, that graph of what's your age versus how many rations of food are you getting per month. Looking at this graph of age versus how many rations the people in these 3 districts are getting per month, we can clearly see there's 3 stripes here. Probably one for District 1, one for 2, and one for 3. Let's be naive and just treat it as one big mass and fit a line to it instead. The only good thing about this line is that it's kind of an average between all of this data, but it's really off between the top and bottom stripe. Let's be smarter and distinguish between the 3 districts. Now we see that clearly we should fit 3 lines, one for District 1, one for 2, and one for 3. And once we do that, we get a much better fit. What happens now when there's a 4th district that comes along? One that's even more in poverty than District 3. We could just do the same thing, fit a line to it, but maybe we want a more general model, where given the data about District 1, 2, and 3, we already can find the line for District 4. We see now that we have a need for a higher level regression. We don't want to have to introduce a whole new regression every time we add a new district. And for anyone who's watched the Hunger Games movies or read the books, there's quite a few more districts after this. So we want kind of a more general model, something that works together rather than having one model for each separate district. Let's go ahead and see how we can do that. As it stands right now, we have a model for District 1, District 2, and District 3, where each of these betas is specific to that district. So this is beta naught 1, which means it's the beta naught coefficient, the intercept, for District 1. This is beta 1, 3, which means it's the beta 1, the slope coefficient, but for District 3. Wouldn't it be nice if we could run a higher level regression to try and figure out these betas based on the distance from the capital? Because once we know the distance from the capital for any new district that we're trying to add, and then if we have some function that spits out our predicted betas for that district, then we already have a model which will help us predict the ration somebody gets per month based on someone's age in that new district. And we're going to do exactly that. We're going to use these following 2 equations to help us predict those betas. So what we see here is exactly a linear regression. So it's pretty much the same form, except this time it's in order to find the betas. So let's just look at how this kind of works. So here we're trying to figure out what's the beta naught for any given district J, given some parameter gamma, plus delta, which is our slope now. So it's the same form as this original equation. It's just now that these betas are the things we're trying to predict, and we have these external other coefficients, gamma and delta. And this is based on d sub j, which is the distance from the capital for any district that we're looking at. And we have the exact same form, just with different coefficients, lambda and mu in this case, for our slope coefficient, beta 1j. So let's go through really fast before we look back at our graphs, how this is working. So let's say a new district comes in, District 4, and let's just draw it in. Let's say here's District 4. And District 4, let's say, is at a distance of 40 miles from the capital center. So now we want to figure out, well, what's the proper equation in this form for District 4? Well, we have to find beta naught for District 4 and beta 1 for District 4. How do we do that? We come to these equations, which were fitted using the data from Districts 1, 2, and 3, so we already have these gamma, delta, lambda, mu coefficients. We go ahead and throw in d sub j as 40, because that's the distance from the capital, and we derive our beta naught 4 and beta 1, 4, which is our betas for our District 4. Now we take those betas, so we take our beta naught 4, and we plug it in here. We take our beta 1, 4, and we plug it in here, and now we have a working equation for the number of rations someone gets per month in District 4 as a function of their age. We throw any given person's age who's from District 4, and we get our prediction for how many rations that person will get per month. Why is this better than our previous way where we just took our data from District 4 and made a model? Well, if District 4 doesn't exist yet, if it's just being formed, and we don't know right now any data about how much rations people are getting in District 4, then we can already have this prediction function before District 4 is even made. So we can try and tell those people, you know what, this is how many rations you should expect from the capital. Make your lives planned accordingly. So let's go back to our data and see what happens when we fit it using this whole technique. So after that whole process, this is our line of best fit for District 4, and we see that's a very, very good fit. This was hierarchical regression in a nutshell. Until next time.